So lesson 2 starts on page 9 if you're not there already. And basically we're introducing a few operations that we are going to be learning with functions. So the 4 that are described are the sum, the difference, the product, and the quotient. Today we're just going to explore the sum and the difference. Okay, so we're going to be looking at 2 different functions, and we're either going to be adding them or we're going to be subtracting them. So let's take a look at notation. If we had f plus g of x, that's the same as adding an f function with a g function. So f of x plus g of x. So this notation is equal to that notation. If you see either or, it just means add them together. Okay, so for example, if I had f of x equals 3x plus 1, and g of x equals 2x. Okay, if I said complete the following, it basically means the same thing as taking f of x, and I'm going to add it with g of x. Okay, so if I'm going based off of this, what was f of x? 3x plus 1. And then I'm going to add it to what g of x was, which is 2x. And then combine my terms. Okay, so 3x plus 2x is 5x plus the 1. And that would be simplified. Okay, so that's basically how I would interpret the operation f plus g of x or f of x plus g of x. You just add the 2 functions together. Okay, same thing with the difference of f and g. If I have in notation f minus g of x, that's the same thing as f of x subtract g of x. Okay, we won't get into the product and quotient today, but we will be next lesson. So fg of x is the same as f of x times g of x. You're multiplying the 2 functions. So rather than adding like we did here, you would take this and multiply it by that. Okay, and the quotient f divided by g of x is the same as f of x divided by g of x. So we would take f of x, 3x plus 1, and we would divide 2x. Okay, why can g of x not equal 0? Yeah, you can't divide by 0. Very good. Okay, so we're going to investigate the sum and difference of 2 functions just by doing a little graphing activity. Okay, basically, just to help describe this a little bit better, these are the x-coordinates. Do you guys remember at the beginning, I think I described, say we had the function y equals x squared. I could write that also as f of x equals x squared, right? So what is another way of writing f of x? Y. So these are pretty much like your y coordinates. So here I have an x coordinate and y coordinate, and now I have an ordered pair. So what we're going to do is we're going to create these ordered pairs, or identify them, and we're just going to plot them on the graph. Okay, so you guys can get started. Oh, there's going to be a storm. Okay, so -4, -7. Let's work that out. -4, down 7. -3, -5. -2, -3. -1, -1. 0, 1. Okay, 1, 3. 2, 5. 3, 7. 4, 9. Okay, then we're going to just draw as straight as possible the line of f of x. So we've basically done part A here, okay? Plot the points x and f of x, and we sketch the graph y equals f of x. Okay, please make sure you label that graph. If you have different colors, we're going to be drawing 4 graphs, so you might want to use 4 different colors. At the very least, make sure you're labeling them. Yeah. We're going to do that one next. All right, you guys all set with your highlighters, your colored pens? So now we're going to plot g of x. So almost imagine that f of x isn't listed there. We're going to create a new set of ordered pairs. So -4, -7, -3, -6, -2, -5, -1, -4, and so on, so on, so on. Okay, so it's almost as if you're ignoring the f of x for now because we're just going to plot g of x. So using the x coordinate and the g of x coordinate. Okay, so -4, -7, let's plot that. Overlap, sorry. -3, -6, -2, -5. And you'll probably realize that it just has a slope of 1, so you can fill the rest in. Bit of a shortcut. So we're ignoring f of x, and we're using the coordinate of x and g of x. Then we can draw a line through. Whoops, I'm going to try that again. Straight line. And this is going to be labeled g of x. How you doing? Don't know what we're doing. So basically the first one we plotted came from these. Anyone else need a little help with how we're getting this one? Well, the first half. There's one, it's like us walking in this. We had a Y in there. Okay, we're moving on. Third graph here is going to be plotting f plus g of x. So another way to write that, just a reminder, is f of x plus g of x. So it's pretty much like we're adding the y coordinates. Okay, what was the y value here? -7, -7. So we're going -7 plus -7. So here we get -14. Okay, again, we're adding f of x to g of x. So on the second row here, -5 plus -6. So we get -11. We're just going to keep doing that all the way down. So next one, -3 plus -5. Now if anyone is confused where I'm getting these numbers, stop me now, because otherwise I'm just going to go through the table and solve for them. Alright. Okay, adding these together, we get -5, -2, +1, +4, +7, and +10. So as you guys can see, it's increasing by 3 each time. So our slope is basically going to be 3. Once you have these y-coordinates completed, now we're creating a new set of ordered pairs to create a new graph, the graph of f of x plus g of x. The x values will stay the same. Nothing's changing there, but now we're going to use the y-coordinates from what we just calculated, f of x plus g of x. Okay, so -4, -14. That's our first ordered pair. Okay, and then -3, -11, -2, -8, -1, -5, 0, -2, 1, 1, 2, 4, 3, 7, and 4, 10. And then just draw a line through those. And we're going to label that f plus g of x. If you're ready, you can start to calculate f minus g of x, which is basically stating f of x minus g of x. So you're taking the f coordinate and subtracting the g coordinate. Okay, to do the first one with you, we're going to have -7, subtract a -7. That's like -7 plus 7, you get a 0. Okay, next one, -5, subtract a -6 is like adding, so we get +1. Next one, -3 minus a -5, again it's like adding a 5, so we get -3 plus 5 is 2. What kind of pattern are we seeing? What's it going up by? 1. And if you do the math, you will actually see that it goes up by 1 as well. So now we have a few more ordered pairs we can plot. So -4, 0. -3, 1, and we're just going up by a slope of 1. And then draw as straight as possible a line through, and label that f minus g of x. So by using ordered pairs, we are able to do specific operations on these functions. Any questions so far? Okay, so there are a few more parts to this question. They're telling us now that f of x and g of x have specific functions. Okay, they're telling us that f of x is 2x plus 1. And they're telling us that g of x was x minus 3. Now what we have to do is calculate. Add these together, and then we're going to calculate how to subtract these together. Okay, so the first one is f of x plus g of x. And I don't know about you guys, but for me, I prefer to read it like this rather than like this. You do need to know both, but I find it's a bit easier. Okay, so f of x plus g of x. Now we're going to sum in those functions. So f of x was labeled 2x plus 1. And we're going to add that to g of x, which is x minus 3. Okay, so f of x plus g of x, we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And we're going to add that to g of x, which is x minus 3. And when we clean that up, we get 2x plus x is 3x. And then 1 minus 3, negative 2. So f of x plus g of x is 3x minus 2. I'll just give you guys a moment. Can you guys calculate f of x minus g of x? See what you get.
I'm just looking at it. Oh, yeah. Okay. You get to see what it is given. Yeah.
Okay, good. So I'm seeing lots of x plus 4. Let's just go f of x minus g of x. And then from there we're going to get 2x plus 1 and subtract x minus 3. We distribute the negative. 2x minus x is x. And 1 plus 3 is 4. So after operating, we get x plus 4. So we could graph these just to see, but what I'd like you guys to actually do is just go back. I'll just show you visually. You don't have to use your calculator unless you want to. Okay, so let's take a look back on this graph here. If you want to flip one back, you can check on yours too. We figured out that f of x plus g of x is 3x minus 2. Let's look at our graph. So f of x plus g of x. What is the y-intercept? Where does it cross? Negative 2. Okay, what's the y-intercept in the equation? Negative 2. And if we take a look as well, what's our slope? It's going up by 1, 2, 3, and then over to the right, 1. Okay, so that is a slope of 3. This does match up. Now let's check f of x minus g of x. We have x plus 4. Okay, let's see here. Is my y-intercept 4? What's your slope? Going up by 1 over 1. Okay, so that matched up. If you still want to graph it, go ahead. Now we're going to state the domains. And yesterday we learned domain and range. So yesterday we learned 2 different ways to state that, the set builder notation and the interval notation. So let's just practice our interval notation. Evan, can you help me out with that? What's the domain of any of these lines? Like if you were to just say it normal.
X is infinity.
Oh, never mind, you're doing it right away. Good job. Okay, yes, it's x is an element of all real numbers. If we were to look specifically at f of x plus g of x, that's the green graph here. Yeah, it's going forever to the right, forever to the left. Element of any real number. In interval notation, it's going from negative infinity to infinity. Okay, what about the roof and the floor? Is it going forever to infinity both ways? Good. There's no restrictions on the y-coordinate, so our range is also from negative infinity to infinity. And now that we know what the functions f of x plus g of x as well as f of x minus g of x are, what we can do for part G is we can apply a number or a value for x and just evaluate. Okay, so if we knew that f plus g of x was equal to 3x minus 2, what will f plus g of 10 look like? What's replacing that x? 10. So, in our expression, we have to replace the x also with 10. And then evaluate. So we get 3 times 10 minus 2 is 28. So just for practice, once you guys finish writing that one down, I want you to try the next one, f minus g of x. But this time, instead of x, we're subbing in a negative 10. Okay, f of x minus g of x we had as x plus 4. We just solved for that above here. So instead of x, what are we subbing in? Negative 10. And from there we get negative 6. Sound good? So the next part, part 2,